Okay, so now let's go ahead and do homework, what's technically homework number 6. It says homework 5 and has the same due date, but this was homework number 6. Okay, question 1. It says let f of xy be 7x squared y minus 5y squared minus 3x. Find the directional derivative of f at 1, 2. So at this point in direction 3i plus 4j. Okay, so the directional derivative at a point in that direction, that's going to be the gradient of f at my point, I'll call it x0, y0, dot d hat. So I put a hat here, meaning that this has to be a unit vector. So first let's find the gradient at that point. So the gradient of f is going to be, let's see, so that's going to be 14yx minus 3. And then with respect to y, that's going to be 7x squared minus 10y. So then the gradient of f at my point 1, 2, so that's going to be 14 times 2 minus 3, 7 times 1 squared minus 10 times 2, which is, so that's 28, that's 25. And then I have 7 minus 20, that's minus 13. Okay, so now let's find, let's normalize this. I need this to be a unit vector. So I have d, the direction, is going to be 3, 4. Okay, but I need to normalize it. I need to divide by the norm of d. So that's going to be 3 squared plus 4 squared, that's 25. 9 plus 16, that's 25, so that's just going to be 5. So my unit vector in that direction is going to be 3 over 5, 4 over 5. So finally, gradient of f at 1, 2, in the direction of d, that's going to be 25 minus 13 dot 3 over 5, 4 over 5. Is that 13 correct? 1 and 2, and this is going to be 7x squared minus, yeah, that's right. Okay, so I do the dot product and I get 15 minus 13 times 4 over 5. Okay, so 16 times 5, that's 80, minus 13 times 4, that's 52. So that's going to be, let's see, 28. And that's the slope in this direction. Right, so here I pick a point. I'm going to pick this point, the point 1, 2. And then I'm going to look along this direction, so 3, 4. So that's going to be about this slope. So in that direction, what is the slope of this curve? And the answer is 28 over 5. Okay, so number 2. It says let f of x and y be 3x squared minus 2xy plus, that's the xy plus y squared. It says, hey, find the unit vector that maximizes the directional derivative of f at the point 2, 3. So find the direction that maximizes the directional derivative. Okay, so if I pick the point 2, 3, right, it's going to be up here, and then I'm looking around and I want to know what direction, maybe it's that one, I don't know, what direction is going to have the steepest slope? Turns out the answer to that is just the direction of the gradient at that point. So what's the gradient? The gradient of f, so this is the direction that we're looking for, okay? So the gradient of f is going to be, that's 6x minus 2y, and we have minus 2x plus 2y. And so the gradient of f at 1, 2 is going to be 6 minus 4 minus 2 plus 4, which is 2, 2. Okay, so that's the direction that I'm interested in. Now, I need to normalize it, right? This is because the question says find a unit vector, right? And when I do this directional derivative, I want unit vectors, okay? So I need to divide by the norm. Well, what is the norm of this thing? That's going to be square root of 4 plus 4, which is 2 root 2. So I divide by 2 root 2, and what I end up with is 1 over root 2, 1 over root 2. And that's the direction that has the steepest slope. So this is the direction of maximum increase. If I did the negative of this, that would be the direction of maximum decrease. Dang it. Okay, so now it says find the maximum directional derivative at this point. So we know that this is the direction of the maximal derivative, but so now if I want the actual directional derivative, I need to do gradient of f dot d hat. So what is d hat? That was this thing from up here, right? This is what the direction we found was in the previous step. And it's a unit vector, so it's this. So I could just start computing, right? This is going to be 2, 2 dot 1 over root 2, 1 over root 2, which is 2 over root 2 plus 2 over root 2. It's 4 over root 2, which is 2 root 2. Okay, so I could do that, and that's totally fine. It's a little bit extra work that I don't need to do because, notice this. What it was this d hat? Well, it's right here. It was a gradient of f over the norm of the gradient of f. And I'm assuming this is all at the point 1, 2. Well, gradient of f dot gradient of f, that's gradient of f squared over gradient of f. Those cancel. So the maximum slope, the maximum possible directional derivative, is just the norm of the gradient. Which we already saw up here was 2 root 2. Right, so the gradient, it gives you the direction of steep increase, and the magnitude of that is the slope in that direction. Okay, so 3, we have that f of t is equal to integral from 0 to t squared e to the x squared dx. And it says find f prime at 2. cannot write when I'm not looking. Okay, so here if we do f prime of something, right, so really here I don't care what variable I have, then this is just going to be the derivative of this. Actually, let me just do it of d. So when I do the derivative of a function that looks like this, oh, that's how I want to write it. Let's see. So if I erase this, from 0 to something e to the x squared dx. Right, so when I do the derivative of something that looks like this, right, what I get is that f prime of whatever is equal to e to the whatever squared. Okay, so here if I put in t, notice what we have, it's not just t here, it's t squared. So when I do this with the derivative, I have to use the chain rule, so I put in t squared, and I have to multiply by 2t. So this is just 2t e to the t to the 4. And that's my answer. No, that's not my answer because I want to evaluate it at 2. F prime of 2, that's going to be 2 times 2 e to the 2 to the 4. So that's 4 e to, let's see, so 2 to the 4, so that's 2, 4, 8, 16. E to the 16. That's my answer. Okay, I'm going to do 4 right next to it because this one's short. It gives us that f of xy is the integral from y to x e to the t squared dx, no, dt. And it says find the gradient of f. Okay, so the partial of f with respect to x. So that's the derivative of this with respect to x. This is just the fundamental theorem of calculus. I just do the derivative, I just take e to the x squared, and that's all. So if I want to do the fundamental theorem of calculus, for the y derivative, I need that the y here is up on top. So I can rewrite this as negative x to y e to the t squared dt. So this becomes negative, and then fundamental theorem of calculus tells me this is e to the y squared. So the gradient of f is going to be e to the x squared minus e to the y squared. Okay, so that's number 4. Let's move on to number 5. So number 5, it's a bit long, but it's basically the same thing. Okay, so here it tells us that, so this is number 5, u of x and t is 1 over 2c integral from x minus ct, x plus ct, g of s ds. Okay, and first it wants us to show that d squared u dt squared minus c d squared u dx squared is 0. Okay, so what I'm going to do is I'm going to write this as, I'm going to break this up into 2 sections. I have 1 over 2c integral 0 x plus ct minus 1 over 2c integral from 0 to x minus ct g of s ds. And then I'm going to start computing derivatives. So du dt. So from what we saw just a second ago, this is going to be, so that's constant stays there. This is going to be g of x plus ct, and then I need to multiply by the derivative of what's on the inside times c, minus 1 over 2c g of x minus ct times the derivative of what's on the inside minus c. C's cancel out in both of these, and then I have negative negative, so that becomes a plus. So this is just 1 half g of x plus ct plus 1 half g of x minus ct. Okay, cool. Now let's do the second derivative. So this is just going to be 1 half the derivative of g, which is g prime, times the derivative of what's on the inside with respect to t. So that's times c. And then same thing here. So plus 1 half g prime at x minus ct times the derivative of what's on the inside, that's minus c. Okay. That should be c squared. Okay, so I'll leave it like this, and let's start computing the x derivatives. Du dx. So this is going to be 1 over 2c g of x plus ct. And then again, I need to multiply by the derivative, but that's just going to be 1. And then I have minus 1 over 2c g of x minus ct. And multiply that derivative. Again, derivative with respect to x of what's on the inside is just 1. So this makes it quite simple. Dx squared, that's going to be 1 over 2c g prime x plus ct minus 1 over 2c g prime of x minus ct. So now I can start adding everything up. So I have this du squared dt squared. So I have I have c over 2 g prime of x plus ct minus c over 2 g prime of x minus ct. So that's the du dt squared plus c squared times 1 over 2c g prime x plus ct minus 1 over 2c g prime x minus ct. So this is going to cancel with each of these, and then we see that these are just this. Oh, this is supposed to be minus. Then we see that each of these terms are going to cancel out, right? This cancels with this one, right? We have c over 2 g prime, c over 2 g prime, and same thing over here. So what we end up with, this is just 0. And that's part 1. Next part, it says show that limit as t goes to 0 on the positive side, du dt. Well, let's just evaluate this real quick and we'll see what this is. So this is the limit as t goes to 0 of 1 half g of x plus ct plus 1 half g of x minus ct. Okay, so if we plug in 0, right, this is a continuous function, nothing weird happens at 0. If I plug in 0, this just becomes 1 half g of x plus 1 half g of x, which is equal to g of x. And this is what it asks us to show. So finally, final question. That was part B. So final question, number 6, it says find, let's see, if u equals e to the x cosine y, x is equal to t squared, y is equal to pi times t. I'm going to write that real quick as r of t is x of t, y of t. And you'll see y in a second. That's t squared pi t. Okay, it says find du dt. Okay, so this is a function of x and y, but x and y are functions of t. So this is going to be a problem with the chain rule. Okay, so here I'm going to do the derivative. Well, what do we mean by derivative? We'll come back to that in a second. Times the derivative of what's on the inside. So actually what that's going to be is going to be f at my point, x at xy, it's going to be, I'll call it r of t, right? Because r is just xy, dot r prime of t. So, gradient of, that's not f, that should be u. So that's the way this thing makes sense. Gradient of u is going to be, that's going to be cosine y e to the x, and derivative of cosine is negative sine y e to the x. Okay, so if we put this back in terms of t, this is going to be what? This is cosine of pi t e to the t squared minus sine pi t e to the t squared. All right, and real quick, let's just calculate r prime. That's just going to be 2t and pi. So gradient of u at r of t dot r prime of t, that's just going to be, I should be using column vectors, but whatever, or row vectors, whatever. So this is going to be cosine of pi t e to the t squared minus sine pi t e to the t squared dot 2t pi. So I do this dot product and I get 2t cosine pi t e to the t squared minus pi times sine of pi t e to the t squared. And that's my answer. Okay, and that's homework number 6.